All right, so thanks everybody for coming for this AI and art workshop. We are going to talk about in the next 2 or 3 hours. So today is me, I'm Han from Gina AI, and also Linus Bowman. He's designer, very a font expert, and also a YouTuber, a very famous YouTuber. So he has a lot of subscribers on his YouTube channels. And I came to know Linus where he has a very, very popular video about there's a, I don't know how many of you watched this movie, American Psycho. There is a scene, there's a business card scene, right? This is you must watch it, how Linus interprets this business card, like in terms of the font designs, all these kind of things. It's very, very, very nice. Right? So that's where I came to know him. And so he also has a very good idea of understanding about AI art, generative art, all these kind of things. And he has another videos only talk about this AI part or AI art part. Right. So today, the schedule is I'm going to first give a talk about AI, creative AI, focus more on the AI part, and Linus later will take over and talk about more on the creative art part. Right? And then later we can have a roundtable discussion on some controversial topics on creative AI or generative AI, such as, is creative artists considered as artists, or they are just like programmers, they are not considered as artists, or is there any intrinsic value of the artwork that created by computer, right? Okay, so to be clear, what we are going to talk about today is, for example, this is one of the creative AI artwork, right, from the early stage, right? So this is created by DALL-E 1, right, the first generation of this DALL-E model, right? So like ocean beach front view in Van Gogh style. And there is also like, you can generate a lot of memes. This is basically what people doing right now, right? With all this DALL-E Mini, DALL-E Mega, DALL-E 2, right? The Statue of Liberty wearing a VR headset. And of course, you can also generate more romantic ones, like a painting a couple of kissing in nebula, right? So very nice. But if you think this is nice, right, then you have to find a word for this one, right? So this is generated using Disco Art, open source software from our company, and this is the artwork that generated. It takes 10 minutes to generate such thing on GPU, right? But you can see the quality, and also it's not memes, right? It is really something, some artwork, right? But later I will also show you the prompts, the text prompts behind this thing. It's also super complicated, right? Compared to what DALL-E, what DALL-E does. Right? And besides the creative art that we are talking about, but if we are talking about today, right? The other thing is the more general concept of creative AI is also including the text part. But today I was not going to talk about text part, right? But to give you an example, I don't know how many of you come to here because of you see the advertisement that I made on Twitter, right? I did some kind of promotion, and actually the promotion text, the text in the advertisement is actually written not by me, but by GPT-3. Right? So what I told GPT-3 is, I'm a highly intelligent Twitter bot, right? My task here today is to write Twitter ads for promoting a Saturday event called Creative AI and Art. This event is looking for attendees like what, right? So my Twitter is super successful advertisement. It is convincing, persuasive, and has a great potential to go viral. Right? And then I copy paste the result and put onto Twitter, right? And that's kind of creative AI on the text part, right? So back to the topic today, creative AI and art. We will figure out what is the source of the AI creativity, right? Come from, right? It sounds very like a philosophical questions, right? And but what kind of CEO am I if I don't promote our company, right? In the talk, right? So, I mean, we are like one of the top AI company startup, in the world. We are founded in 2020 in February. Right now, we have 50 people. Our headquarters is in Berlin, but we also have offices in U.S., in Beijing, in Shenzhen. So we have listed under CB Insight AI 100. All these top glorious leaderboard. right? We contribute a lot to open source, right? This kind of all the open source framework, software that you can do a lot of things called neural search, right? But how is the neural search even related to, the topics that I'm going to talk about today, right? So basically, I will divide my talk into three parts. So first part is, of course, talk about neural search. So this is the foundation to enable creative AI. And then the second part is, of course, creative AI. Inside this part, I will talk about GPT-3, DALL-E, and Diffusion, right? So these three very intelligent AI. How do they work? And finally, I will give you an example to show you how Discord art really built the artwork, where the creativity comes from, right? So the first part is neural search, right? To understand neural search is very simple, right? So imagine you want to search or look for a sentence, right, inside a book, like Pride and Prejudice, right? You want to search for a sentence like she smelled too much, but you don't want to search exactly. You want to search, so you are okay with if the result is she laughed too much, right? I can accept it, right? So it's kind of like there is some fuzziness. So you're not measure the match by character, but letter by letter. You are measure the match by some semantic meanings, right, of your input. So this is one example, right? So you can easily use Gina to implement that in just 15 lines of code, but because we're not very technical conference, so I will just skip this part. And then the second example is, let's say, right now it's very common in the e-commerce company, you buy a shirt, you buy a dress, and you right-click on the shirt or dress, you can look for similar, like a recommendation, look similar dresses, right? This feature often in the e-commerce company is called shop the look, right? Shop the look. You want to you want to take a photo of yourself or some like street pictures, and then you want to upload to the server, and then server returns some visually similar dresses from their database, right? So this is a very typical applications of neural search, right? So you can also easily do this with Gina, with our framework. And then let's put it about on another level. Let's make it more difficult. Let's think about if it is not image, if it is like a 3D mesh, right? How can you do this, right? So this is more difficult because the 3D mesh is not an image. It is actually a dots, vertices, right, and edges, right, faces, right. So there are a lot of information in this 3D mesh. How do you quantize it? How do you define the similarity between one 3D mesh and the other 3D mesh, right? So this is also application of neural search, which can be easily solved by Gina. Right, and then the last one is very good old chatbot, right? So let's say we have a question answering all these kind of things. So you can ask a question about documentation, and then it will answer you. It will find out the answer and returns to you. So compared to the traditional or classic like a Google-like search system, so this search system is so accurate that it's so confident it's just directly return you the result. Right, return you the answer. And when it doesn't know the answer, it will just answer you, I don't know. I cannot infer this question from the database or from the knowledge base, right? So this is also an application in neural search. So I don't want to go very details because this is not the topic today, right? But it helps us to understand what is neural search, right? Why do I have to even talk about neural search? So neural search is deep neural network based information retrieval across or inside different modalities, right? So one can describe neural search as, the data is there, right? It's objectively there, right? And then you want to use the relationship to find the data, right? So you can imagine, I don't know how many of you recognize this character. It's Doraemon, right? It's a very, I'm Asian, right? So I watched this Doraemon back in when I was a kid, right? You can imagine neural search is like this, right? So you have a Doraemon has a magic pocket on his belly, right? He can pull out a lot of things, but the things must be there, right? This magic thing must be there. He cannot invent something out of his pocket, right? So he's trying to use his his brain or whatever this relationship to find the right data for you, right? This is neural search. So remember this graph because I will later come back to this graph with the creative art part, right? Okay, so is neural search a solved problem? Actually, no. So there are a lot of technical issues, engineering things, but you don't have to worry about this because our company provides all this framework to help you to bring to solve all these things and bring it to the production, right? Okay, so now let's jump to the creative AI, right? So for creative AI today, I want to cover like GPT-3, DALL-E, and Diffusion. These three very typical creative AI of the three models in creative AI. So let's first start with GPT-3. Right? So like what in the beginning I said that this Twitter ads is actually read right by GPT-3, right? I mean, it sounds very like very impressive. It is very impressive, but if you look at the technology itself, it's not something new, or it's not something completely groundbreaking, right? So for example, if I write a sentence like this is a goal, and then I ask you to predict the next character, right? So you can of course say, oh, this is a god, right? This is a GOL, and then this is a gold, right? This is a good or something, right? It's very easy. So you have the kind of very straightforward to predict based on the sentence that you see right now, and then what could be the possible next character, right? But let's level it up this a little bit, right? So let's level up. Let's say, okay, so you already complete the character. You can already complete on the character level, and I ask you to predict the next word, right? And then of course, with this is a goat, and then you can complete with a fish, mountain, gold digger, right? All this kind of thing. And of course, those techniques are very, very common. It has been there for the last 20 or even 30 years, right? For example, the spell checker starting from Word, Microsoft Word, 1995, right? So it already has this capability of predicting the next character that you are trying to input. And Google autocomplete, right, has been there for at least 15 years or something, right? So it's not something new technology, right? But I want to use this meme to represent, right? So you can actually say, okay, so next character is solved, next word is solved, but how about the next sentence, right? Can you write one sentence and predict the next sentence? Can you write one sentence to predict the next paragraph? Can you write one sentence and then predict the next whole chapter? Or can you predict the whole book, right? So of course, this corresponds to different intelligence level, right? And this intelligence level, again, corresponds to different knowledge that requires to build such intelligence, right? So for example, to predict the next character, probably you just need to know all the alphabet, right? That's it, right? And to predict the next word, at least you have to know what are the possible words in the dictionary, right? So probably you are very good, you have a very good memory, so you don't know what this word is used, but you know all possible words from Oxford Dictionary, so that would be enough. And then in order to write the next sentence, you probably need to read one or two books in order to understand how the grammar structure looks like, all these things. And then in order to write paragraph, you probably need to read a lot of books, right? And of course, the next chapter, you have to read even more books. So for OpenAI GPT-3, so the intelligence level is around this, city library and let's say this is state library, right? Let's say around this, in between these two things, right? So this is like a university library, this is state library, right? Okay, so, but in general, we can just summarize this, all the mathematical models, AI, computer science into this simple formula is given the past, what is the probability of the future? That's it. That's the simple conditional probability. And in order to, and then you can, based on this, you can derive two kind of future, right? One is very deterministic and rational future. You basically maximize the probability to find the future that gives you the max value, right? This is very rational and is deterministic. On the other side, you can be very creative, and the creative is just a sampling from this distribution, from this probability, right? So in that sense, you don't have to thank all this AI progress, in the last 10 years or deep learning progress. You have to thank all these three old guys, right? Thomas Bayes, who defined the foundation, who set up the foundation of probability theory, especially Bayesian theory. Andrei Markov, who set up the foundation of Markov chain, right? And Claude Shannon, who defined information theory, right? So those are the three pioneers that from 1700 to 1960, right? So those three pioneers set up the foundation of today's GPT-3, right? So in some sense, but of course, if the technology doesn't develop, right? If there is no information revolution, then nothing will happen, right? Because they all just stay on the paper, right? So they're just theoretical, proof. There's just theoretical evidence. There's no practical. There's no implementation. So thankfully, due to the information revolution in the last 50 years, the computer keeps evolving. The hardware, software keeps evolving, and today we really have the computational resources to implement such thing, to move it from academic papers to practical use, right? Okay, but then here comes my shower thought about creativity. So people always say, oh, human has creativity, computer doesn't, right? But isn't creativity, by the way, this is just like my own view, right? So it could be very pessimistic, right? So isn't creativity just a result of searching all the possibilities, right? Especially those possibilities that human or people have not explored, right? Right? It's not something very unique, right? If I'm a supercomputer, I can enumerate all possible possibilities faster than you, right? Then I am creative than you, right? And the other thing is, if I think in this way, right? Okay, so then supercomputer can be creative, right? But people always say, oh, you have to be self-aware. You have to know who you are, right? Who am I, right? So people always ask this philosophical question to ourselves and also to computer. But let's say in the worst case, let's say after 100 years, humans still found out that AI cannot have basic self-awareness or consciousness. Are you willing to accept AI as intelligent species? Right. I mean, it's not the first time human races, right? Like see one race is better or lower than the other race, right? If at the end of the day, there's no way to implement an AI with self-awareness, with a soul, with a consciousness, then do you accept AI as an intelligent species like human, right? I mean, these are open questions, right? So I don't want to go very, very deep. And so I just throw it here so that you can use it as a conversation starter in the coffee break. So now let's come to the DALL-E, DALL-E 2, this thing. So you already see how powerful it is. So basically, you can generate a lot of images from the text, right? So text to image. Unfortunately, it's not very easy to understand. If you dig into the algorithm behind, there are a lot of first of all, this is not open source. So OpenAI never published the source code. So it makes it very hard to understand what is really going on. But fortunately, OpenAI published a lot of academic papers. So people reverse engineer those from the academic papers and figure out, okay, so what could possibly going on inside the gray box, right? So in order to understand DALL-E, you need to understand these 4 fundamental papers that published in the last 5 years, right? The BERT, the natural language model, variational autoencoder, clip model to the diffusion net, right? So I won't go into very details, but so as you can see, DALL-E 1 is published by OpenAI in last year in 2021, and then this year they published DALL-E 2. But the change in the middle is just like they add another diffusion layer in a diffusion model in between to make it more artistic and generate higher quality image, right? So we actually provide open source software like a clip as service DALL-E Flow. So you can try it out. It's basically like a community version of the DALL-E and also the community version of the clip, and then you can use it to build your own text to image system, right? So today I want to focus more on the next level thing, on the diffusion model, basically the very artistic artworks that I showed you in the beginning, right? For the diffusion model, it works like this, right? So you start with
with a high quality picture, right? And then you keep adding the noise. You intentionally keep adding the noise until you cannot see this picture anymore, right? And then you build a series of neural networks, try to decode, try to reduce the noise, try to recover the original high quality picture, right? So once this series of neural network is trained, you can use this neural network to decode any images from the noise, right? So that's why if you see, so by the way, this is animation from Disco Art, generated by Disco Art. It's not really animation, but it shows you how the decoding procedure goes, right? You can see it starts from random noise, completely random noise, and start to decode as volcano, mountains, Amazon, this forest, all these kind of things, right? So everything starts from random noise, right? And this is again like a city, like I want to describe it like Barcelona, right? But I never use the word Barcelona. So instead, the prompt behind it is very complicated, right? So you can see the text prompt is a beautiful illustration of breathtaking aerial landscape of this example. I think Linus probably knows this. This is kind of like an architecture style, very popular in Barcelona. That's why the city is built in that way, right? So like a grid things. And then you can see there are a lot of modifiers, like a wide angle, bright arrow, like a theme, and then watermark, no signature, no text, no 3D, these kind of things. So you can see there are text prompt, and there are also weights associated with the text prompt. And then you can use this prompt to generate this image, right? So this is one of my earliest attempts. So I write a lot of prompts, to set up the image correctly. But then this is like my later, after 2 weeks, I kind of mastering this prompt. I become a prompt engineer, right? and you can see this is, now I'm very satisfied with this. Like I personally, I never had the talents to do this kind of painting, but I'm able to write a program to generate this thing. And if you look at the prompt behind, right, it's just a 3 sentences, right, and then with some weight, right. So basically, I just write all this as a crater lake with blue sky filled with giant green, yellow, purple clouds illuminated by aurora, polar lights, icy blue mist, morning short. I just put a lot of words inside, right? And then here, the second prompt is basically all the enemies that I watch, like in the weathering with you, the place promise in our early days, 5 centimeters per second. So your name. So these enemies are all from this Japanese artist, illustrator, this Makoto Shinka, right? So if you know him, then you know all these enemies, right? And of course, I don't want this to be very fuzzy, dubious things, so I add a lot of modifiers to say, okay, no people, no shadow, no blur, all these kind of things, right? Yeah, and there are also some other artwork that I generated, using Disco Art, right? So this is like some kind of like a building with trees, trees growing on buildings. And you can also use it to generate like faces, portraits, right? So this, in the people later post is a portrait diffusion model, which allows you to generate very good-looking faces, right? So if you compare DALL-E and diffusion, right? So this is a experiment that I did when I forcing all the parameters are the same, right? For all the texts are the same, right? Fixing everything the same. And just try to input the DALL-E's picture into diffusion, and then you can actually see that the quality gets improved, right? The image becomes less fuzzy, and it becomes more clear and more confidence on a lot of details, right? So I think this table actually summarizes everything very good, right? So if you use DALL-E, you get things very quickly, right? You get a prompt, a text-to-image can be finished in just 10 seconds or 20 seconds. But if you use diffusion, right, on the latest GPU, it probably takes you 5 minutes to finish an artwork, right? But the quality, of course, the diffusion is on the next level, right? It really add a lot of artist element into your artwork. Right. Okay, now let's come back to the creative AI part, right? So let's make a summary. What is creative AI? So creative AI is basically using deep learning power to do content generation on cross and multimodal data. So why do I emphasize on the cross and multimodal data? Because if you think about GPT-3, GPT-3 is working on the text domain, right? But the point, the key here is the data is not there, and then you want to make some data out of nowhere, right? For example, where I use GPT-3, I only write the prompt, right? The advertisement, the Twitter advertisement is not there. So I want GPT-3 to make some data for me, right? When I use DALL-E and when I use Disco Art to make artwork, the picture is not there. I only have text data, right? So the data I want to generate is not there, right? I want to use a relationship to make some data out of nowhere, right? So if you watch Rick and Morty, right, then you know Rick is a very smart scientist who can make anything that if Morty wanted, right? Like a save load, this kind of machine. I remember save load, remote control, all this kind of thing. He can basically make anything out of nowhere, right? So if you combine all these things together, then you see the big picture. Why I say that neural search and creative AI is related. Neural search also handling all the cross-model different data types in different modality, like image, sounds, video, audio, all this kind of thing, right? And creative AI also handles this thing. Although right now we are only see creative AI being very active in the text domain and also in the image domain. But I believe in just 2 years, we will see creative AI to generate video from nowhere, right? And actually there are a lot of research already going into this direction, right? So, and then combining these two things together, or these two pillars together, you see the big picture of the future application is actually about cross and multimodal application. And this is what Gina AI, what our company is going for. Right? And then, of course, you can compare this side by side, Doraemon versus Rick, right? Yeah. Okay, so as the last part of my talk, I will try to break down the Disco Art. It's an open source software. You can go to GitHub and then check it out. You can run, if you don't have GPU, you can run on Google Colab, free tier. It is also runnable without any problem. So using that is very simple. You just install Python and then from Disco Art import create and then do create. That's it. Actually, it is oversimplified because the default prompt is a beautiful painting of a singular lighthouse, blah, 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 trending on art station, and with a yellow color scheme. Right? So that's a default prompt. But if you don't specify anything, then you just get the, you can just use create. Right? Okay, so this is so let's see. So if we, so this is like a 6 trials that I just generated with 50 steps, right? So you can see there, it's actually more artistic compared to DALL-E, right? And to be honest, this is still in a very low quality because I usually do like 250 steps, and this is only like 50 steps, right? But as you can see, it all starts from random noise, right? Okay, so now I try to explain how it works in very high level, right? So we all know that this is how diffusion works, right? As I explained, right? So you add, in the training time, you add a lot of noise until you cannot see it anymore. And then you build up a serious neural network, try to decode from the noise data until you get the original image, right? So I want to answer 2 questions because there are a lot of questions about how it works, right? But here I just want to explain 2 things. So first, where is the creativity come from, right? And second, where is the supervision come from? Right. I mean, all the other things, how is it implemented, how the memory is managed, that's not the concerns of this meetup, right? So to understand the creativity, we can do an experiment like this. We can write a text prompt saying that you can generate anything, right? Text prompt is anything. And then the model will try to figure out what anything means. It's basically like, oh, I'm free. I can follow my free will, right? So then try to figure out something. But it's nothing. Look at this picture. They start from random noise, and then it goes nowhere. It looks like I don't know what is this, right? But this is true. So without any supervision, the diffusion model is trying to decode into something completely random because the creativity means nothing if you don't add any supervision on it, right? And very interestingly, all right, so even if you fix the seed, fix the random seed, and then you see that the whole start from the same noise, fix the random seed, and then you try to reproduce the artwork. It's actually not possible. It's only near reproducible. So people talk about NFT, all this stuff, and then I call this NPT. You can either call this a non-reproducible or near reproducible token, right? And then you can see this is exactly from the same seed. If you look at the first picture of the noise, if you pay attention to the noise in the beginning, you see that they come from the same noise, right? You see that there's some similarity between the steps, right? Especially the first three comes from the same noise. The second part from another noise with the same seed, right? So this is for example, this is experiment one, group one. This is a second group, and then you can see that they come from same noise, but then things start to diverge into completely different, not completely different results, right? You can still see the composition is kind of follow the same composition. The lighthouse is here, the lighthouse is red, and there's some green, yellow wave here. And in this picture, the lighthouse is always in the middle. But you can see this is, so for example, that one looks very different, right? So this is like a butterfly effect, right? It's basically when you do the diffusion model, the arrows start to propagate, right, over steps. In the end, you can not guarantee that the artwork is reproducible. Right? So this is very, very interesting. And people do a lot of engineering work just to try to solve this reproducibility problem, right? Okay, so the final thing is, the two things, basically that answer where the creativity come from. The creativity come from sampling and random noise, right? And so that's where the creativity of the disco art come from. And then, so what is the supervision? Where is the supervision come from? So in this case, supervision is iterative procedure, right? So basically, in the disco diffusion, you try to, for each step, when you do the denoising, you try to make a lot of cuts. You try to make a lot of small pictures, right? And then you use clip models to ask, and then ask the clip, right? So you can say, so your prompt says, the user says they want a dog in the prompt. Is this a dog? Right? So basically ask this question, literally asking clip this question. And then the clip will return you yes and no, right? So I want to show you a demo. So you can actually find this demo on Clip as Service, right? So if you go to visual reasoning, right? And then you can see there's, so for example, let's look at these pictures, right? So you can see, you can write some prompts, and then here it will show you the possibility or the likelihood. Maybe I just open this in another, yes. You can see, you can choose a picture, let's say choose this one, and then you can see on here, you can see the possibility or the likelihood of each prompt, how likely it is, right? Of course, you can also delete the prompt. You can say, it can also do basic counting, right? So you can say there are one berry in the picture. So look at the speed, it's real time, it's super fast, right? And then you can say there are all 4 berries. And then let's remove the last 2 prompts. Oh, you can see that it's actually, it can tell there are like a plural berries in the pictures rather than one berry, right? So basically, you can use the clip model to do a supervision. And this supervision is very intensive. It's actually added on every step in the diffusion, right? And then you use this step, you use the feedback from the clip model to steering the direction of the next step, of the next diffusion step, right? So it's basically like Asian parents, right? So where they look at the children and they say, oh, you cannot do this, you cannot do that, and then on every age, right? On, on average age, even you are like a 33 years old, right? So like your mom still tell you like you can do this, not that, right? So it's like that, right? So it's very intensive supervision on the creativity, right? So that's in the end, putting this creativity and also the supervision together, this gives you, very nice artwork, right, like this. All right, so that's basically it, right? So as a summary, right, so I want to, today I talked about the neural search part and also the creative AI part. I said that there are two pillars of cross and multimodal applications, which is the future of AI, of software development, right? I also talk about how the GPT-3 DALL-E disco art works and where the creativity come from, right? And so if you like us, you want to explore disco art, you want to try it out, then please just go to our GitHub. You can play it for free. You can tweet about it. Make it viral. Yeah. So that's it. That's it for my talk. And thanks a lot for your attention. Yeah. Yeah. All right. So I can do a quick QA right now, and then we do a coffee break, and then followed by Linus talk. Right. So any questions right now? Yeah, please.
I'm really curious about when you talk about the non-reproducibility. So if you have a fixed seed, I understand that the two main sources of let's say, random would be the noise that is added, which if you have a seed, and then the cuts, which can change. But if you have a fixed seed that gives you the same noise added and the same cut, how does it's getting? You said precision, but how is it working?
So I told this in one of the discussion on Discord. I said that the randomness could come from three sources. The first is the floating point, the precision of the floating points in the computer, right? And secondly is on every step, the diffusion modeling is actually doing sampling. So it is already very randomized procedure, right? So it's trying to sample from the from the complete noise, try to recover sampling the last step, and then from this sampling the last step, and then until the beginning, right? And this is in the practical implementation, this procedure is often very long, and then the error. Let's say there are some decimal errors or floating errors here, it will propagate over time, right? Until you get different pictures, right? So I mean, the third reason could be a bug, right? It's most intuitive thing. It could be a straightforward thing. It's a bug, right? Yeah.
Interesting. So you say it's a very chaotic process. And
yes.
Even a small, I don't know, this time it rounded up or it rounded down this number?
Yeah, yes.
Okay.
Could change a lot in practice, yeah.
Because I think people doing experiments where you try, for instance, to just vary one parameter, like there's a lot of people doing several one of these, and I guess this affects a lot of it, and I had under the impression that you could control a lot this, so no, you're saying that up to this point, disco diffusion is not.
Yeah, I mean, it could be a bug that we have to figure out, because disco diffusion also involves a lot of models. It could be there are some model that didn't control the random seed strictly, right?
Okay.
Yeah. Yeah.
So the two first two
Yeah.
slides that you showed about the speed and the diffusion one.
Yeah.
You said that the diffusion takes 5 minutes, 5 to 10 minutes to get to high quality.
Yes.
But that's because of the clip.
That's because two things. You can diffusion is an iterative Markov chain. It depends on time, right? Yes. It's first of all, it depends on time. You always have to sample, iteratively based on the last image, right? And then secondly is there's a clip supervision added on every step of the sampling, right? Yeah. So that's why it is slow. Yeah.
And the clip model that is specially trained with noise images as well?
No, a clip model is different. Like diffusion model is trained on noise image. It's right. So you can basically use diffusion model to do upscaling. You can use diffusion model alone to do upscaling. For example, this is one good example. If I don't add any text prompt, I just use DALL-E this image as initial image and then feed to the diffusion model, and it actually upscales the image. Right? So you can see the details get improved, all these kind of things. Right? And then the clip model is trained on general data, like the internet data. Right?
So how does during the intermediate denoising steps, how is the clip model able to guide it when it's still a noisy image?
Yeah.
You said within the intermediate steps,
Yeah.
you're also using clip to guide it, right?
Yes.
If
Yeah.
clip has not seen noised images and only trained on nice images,
Yeah.
how does it guide correctly?
You can trust the clip is powerful enough to recognize a noise image. This is a capability where people call it zero shot, right? Zero shot capability. So basically, it describes that in the traditional machine learning, usually in order to make a model work, this model have to see these similar things in the training data, right? So, or like usually people say, oh, this model is so powerful because it only requires so few training data. This is called few shot, right? Few shot learning, right? But in the clip model, you don't have to worry about this because it has the capability of zero shot. So even it doesn't recognize, even doesn't see this thing, this object in the training data, or it is this noisy picture in the training data. So it can figure out, right? So this is basically why clip model is groundbreaking, where the other like a CNN, like improved CNN, all this kind of thing are kind of fall in the same family of technology. Yeah.
So what does the model do if, for example, the likelihood of the image being generated by that prompt is decreasing?
The
Previous iteration, for example?
Yeah, I will try to steer the yes, try to tune the weight, try to gear the the diffusion procedure into the right direction. Basically, everything is controlled by a loss function, right? So basically, it's like in this procedure, in this iterative procedure, when you after you ask a clip for guidance, it will respond with a loss, right? So with a quality, how close you are to the text prompt or how far you are away from the text prompt, and then you use this kind of supervision to steer the direction of the next step. Right? So it's very, very computational intensive procedure. Right? Yeah. Yes, please.
It would be a bit of a very nerdy question.
Yeah.
So it's all right if it gets too much into detail. But like, since you're using clip, I was wondering what you, if you're familiar with and what you think about like techniques like classifier-free guidance, especially in the context of diffusion models, or if there is like some inherent benefit to clip that you see as most important for it to
Yeah, I think a clip model is I never tried this classify phrase this diffusion things, but I think clip has its own charm. So first off, it's a zero shot, right? And secondly, like this right now, OpenAI released some pre-trained clip models, which is trained on a lot of data. Right? They're super powerful. And secondly, people can fine tune on this pre-trained model. So let's say you want to build a diffusion model or disco diffusion that works very good on anime data, right? You can fine tune the clip model on anime data and then use this clip model, use the same structure, right, to do the to make sure that the generation is more anime style, right? But what I do think is that the current disco diffusion, although it can generate very artistic things, but to me is feel like a lot of over engineering, right? The whole thing looks like is this really necessary, right? There must be some smart way to avoid this computation, right? I think this community right now is still probably in the early stage, but as the research and engineering work about generative art, creative AI come into public spotlight, then I believe this area will speed up a lot. Right? We already see this area speed up, since DALL-E
DALL-E 2, Mid-Journey, right? And this is definitely speeding up. I see this is the most active community, right? Discord community that I have joined compared to other general AI startup, general AI community on Discord channel. This is a very, very active Discord community. Yeah.
If you go to the Barcelona prompt,
Yeah. Yeah, this one.
how did you prepare the training data so that the realism can be subtracted, or you can give like weights to the digital art paper, wallpapers to be 10? Like how did you prepare the training data so that
So training data is nothing just a web caption with if you for example go to the clip font. So this gives you an idea of how the training data look like. So for example, this is an artist, right? And then so let's look at let's search for another thing. Let's search for white desert. And then you can see this is basically the training data, right? So where you have these pictures, and then you have some descriptive text of this picture, and that's it, right? It doesn't necessarily to be a full sentence, and then the clip model will do a lot of things. So first, it will try to figure out the the relationship between different words, right? I try to figure out, stands is usually yellow, but this is white sand. What is going on there, right? So this kind of things. Try to figure out the composition of the language, right? And also try to associate the composition of the language to the composition of the image, of the visual modality, right? So that's basically how the clip is doing.
is only doing inference that you do the weights and not doing
Yes.
training?
Yeah, there's nothing special in the training, right? Of course, but if you, let's say, as I said, if your training data is full of enemy pictures, then of course, if you train on that, you get better quality, right? Because your clip is fine-tuned or specialized on this enemy data, right? But let's say if those are just web pictures, right? So like a laptop, stock image, laptop, then it's just it's just like this, right? So there's nothing special. There's no artistic about these things, right? So it's just like some laptop things, right? Yeah. Yeah, please.
For that same prompt, you had one really long sentence at the top,
Yeah.
but it seems also naturally split up into chunks.
Yes.
What would be the difference if you split those out into new lines?
That will be competing, right? So the thing about so later I also noticed this this thing. So if you compare this prompt combination versus this one, this is more structured, right? Actually, usually in Discord diffusion, the rule of thumb is having 3 prompts in a list. 3 prompts. The first is what we call the major prompt or main prompt or main theme, right? It describes everything that you wanted to show, right? The second is called the positive modifier, right? Positive. You want to somehow gear the image result into that direction. And the last one is called the negative modifier. It's something that you try to avoid. You try to, for example, I want this picture to be fully like a landscape picture. I don't want to see any human or like a computer in this thing. And also here is also a little bit pity because it doesn't respect my prompt on no signature, right? I explicitly say that. Text and signature, please no, give it a 3, -3, right? But it doesn't respect this, right? Probably he's so ego, he said, no, I create these things, I must put my stamp on this, right? It's not yours, right? Right. But that's the rule of thumb. If you have too many of these kind of things, then algorithmically, they are trying to compete to each other. Right? In the end, you will get a very weird thing. If you put that into the same line, right, in the same quote, right, then they try to jointly contribute to the image, right? So basically, the conclusion here is if you put that separately, then they are trying to compete with each other. And then if you put that into the same line, they jointly contribute to the image, right? But in order to really understand, you have to really dig into the loss function, and then you can see it more clearly why this is happening. Yeah. Any other questions?
Oh, I have
Yeah.
a small question. The negative prompt that you give, is it directly given to clip as such, or do you specifically say that go towards this direction and go away from this direction? Go towards the positive direction and go away from the negative direction. Do you have like separate losses, separate like text to clips, or do you do it like with this exact same?
The exact the same. It's just like after you compute the loss function, and then you just times multiply the weights, right? If it is positive, then it's good. It is negative, then it's just like pushing in other direction, right? Actually, I also have a very interesting experiment about the negative prompt from the Discord channel, which there is yes, I will send some ads here. Okay, so if I go to this channel, by the way, this is a very good channel. So community, you should definitely if you are interested in this artwork, right? So you should definitely join this channel because you see people share a lot. Very very nice artwork. So somehow this network is not very good, but you can see here, right? So what also you can see, I did an experiment about Apple from, let's see, here, right? So basically, I tried to do two things. One is I tried to do a pure positive prompt called Apple, and then gave it to like a weight, like a 10. And then the second experiment I do not Apple. That gives it -10. It's double negative, right? Double negative should be equals to positive, right? And then this is my experiment. Okay, so this is double negative, which gives you nothing. And then if you just write apple, then it gives you some kind of apple, right? So this is a very interesting thing. It also shows that although clip is able to do certain visual reasoning, as I showed, it's able to count the berries. The number of berries is a plural. It's not singular, right? But for this kind of double negative things, it's very hard to figure it out. And this is a very interesting example. It's basically generate this kind of very weird creatures from the double negative things. Look at this. This is not apple -10, and then it gives this picture, right? Yeah. Yeah. Okay. So yeah, so it's very like addicted things, which we will talk about this later, right? So I actually have this like why creative art is so addictive, and then it's like gambling, like a porn, or this kind of thing. So we will have this random round table afterwards, right? So let's take a break and go ahead and grab some coffee, snacks, right? Let's come back later. Come back later for Linus talk.